Ayush, hi, this is Krishna here. Could you just revise the
And
complete tract once so that they will have clarity from the start, from step one? If you could just revise the contract till now, that would be great. Thank you.
okay, just give me 1 second. So let us start from the start. So what we're doing, we're creating an NFT marketplace. So if you think of a marketplace, you will see that there will be a 4 5 functionality you need to have in a marketplace. For example, a user can come to a website, mint an NFT, list our NFT. A user B can buy an NFT. If a user B again want to resell our NFT for updated price or change the price of the NFT, he can do this. So we're gonna build a smart contract with four five functionalities. For this thing, we're gonna build NFT. First of all, we're gonna allow user to mint NFT. To build NFT, ERC721 token is a standardized token by Ethereum Foundation. Is it this smart contract and we import this using this link. Apart from that, we also use ERC721 URI storage. If you click on this library by using control plus left click, you will see that this smart contract even just import other custom logic is used. Why we are using this thing, I will tell you in future, otherwise you will get confused. And we use counters. Why are you using counter? Because counter till now it is believed that it is unhackable. If you use plus plus for token IDs, good smart contract hacker can hack your smart contract and can manipulate your NFT token IDs, which is very bad. That why that is why we are using counters. These three lines are doing that for token ID. Token ID will be 0 1 2 3 4 and item sold. This item sold will be used to filter our smart to filter which NFTs are sold and which NFT are still in the marketplace. Apart from that, this is listing price variable. So basically, we are telling our users that this price you have to pay 0.050 ether to list your NFT in our marketplace, and we're gonna build a custom logic. So basically, whenever we get sell NFT sell on our platform, that 0.050 ether will be sent to the owner. Now, to set this thing, we need to create a payable owner address. So this function or this variable do the same thing. Address payable owner. Why we are immutable? So immutable allow us to set a value of a variable only once. After that, it become constant and we cannot change the owner. So basically, why what we need for NFT is unique token ID to see who is the seller of the NFT. So basically, when the NFT will be sold, the value of the NFT will be transferred to the seller address to get this payable. And that address will be a payable address. And owner who is the new owner of the NFT, price, and sold. For example, if this NFT in our marketplace contract, the owner will be the marketplace smart contract. The moment it is sold, this address will be changed in address payable owner variable. Again, event is just like console.log for JavaScript. It write function on the blockchain explorer. Whenever you use protocols like Chainlink, the graph, push protocol, and any good protocol, you need they are event listeners protocol. They can't read your smart contract. They will listen to the events. So whenever, for example, you click update listing price, they will not know that price is updated by this. But if you add event in it and create event here, and emit event here, then they will know that price is updated. So thing is to keep track of the status of the NFT. Constructor we use constructor to set the owner. Again, need to change the price. For example, right now is 0.050. If you want to update to one matic or two matics, we can use this function. Now I guess let's move to the next function. If anyone any doubt, I'm open.
For the 721 contracts,
Now graph and again. Okay.
hello.
Hello. Yes. Yes.
For the 721 contracts, we are importing from the open sampling
Hello.
contracts, right?
Not really. Basically, the ERC 721 is the accepted standard for creating an NFT. And Open Zeppelin is a company that created that smart contract for us. So think like that. If you
So
create a
we are not importing from open sampling, right? Then
we are importing, think of a company who created a ERC 721 standard in collaboration with the Ethereum Foundation. They have the standard thing set for other developers so they can build on it. So putting smart contract ERC 721. But that ERC 721 is typed or created or built by Open Zeppelin.
okay. So
You get my
can we
point?
not simply copy the 721 contract which is on the site then?
Sorry,
Can we copy the 721 contract which is on the site?
sorry, bro. I'm not understanding your point. You're saying 721 token on the site.
Yeah, so there are 720, the code is there, right, on on the website.
Krishna Kevin is asking. You want to know where how we are importing this thing?
No, leave it. I will ask Krishna after, or I will call you afterwards. Okay?
Okay, do one thing. I will send you Twitter ID, my Twitter ID. Type the question. I will tell answer. I'm not able to
Yeah,
understand your
okay.
question. So update listing. So if you remember yesterday's lesson, this is the setter function. We are setting the new value of list price variable. Now we get this function for the read functionality. In do update listening price now set listening price public view returns. It's pretty standard thing. UNT 256 because we are fetching the value and then return listing price. Could we done this thing? Easy peasy. Now this thing we're gonna create token. Finally, we're gonna create an NFT. You function to create or mint NFT tokens. And IPFS will going to give us a CID, a content ID in the bytes form. So we're gonna use the thing, sorry, in a string form. For that reason, we're going to use string memory token URI and price. Now, this is the most important function. If you understand this function, this you can understand all the smart contracts. So I'm gonna repeat it again. For instance, think of it in a front end. Think as a user. You come to a platform for mint an NFT. We're going to allow user to change the price of the NFT whenever he likes. So the price will not be stored on IPFS because one thing once a image or any media file is uploaded on IPFS, we cannot update it, we cannot manipulate with it. It is told, it is told. We cannot change it. It is immutable. So apart from a price of the NFT, he has to put the name of the NFT, description of the NFT, and the media file, that is image or video of the NFT. So that NFT will be converted. All the metadata of the NFT will be stored on IPFS. IPFS will give us CID. That CID is in the string form. So we're using that string form and place it here. The price will be here as the params. And then we're going to use a custom logic to mint an NFT. Again, if anyone has any doubt on that, please ask me. If you understand this function, this smart contract is yours. So let's build this thing fast. Token ID, okay. Again, this increment thing is come from the counters library we have imported. Oh, same with the current is the function we are importing from counters library. So what we have done till now, we increase the token ID from 0, set the new token ID that is current value. Now then we mint the NFT. This NFT functionality is came from ERC 721. We don't need to put all this custom logic, check, uncheck before transfer things are there. Are this thing is taken by the ERC 721 library. So simply use mint function, message to sender, the person who click on that create token function and new token ID which we use in this custom logic and set, and this thing is mint. Now set token URI. The reason why we are importing URI storage.sol instead of just ERC721 is because we are using URI, or you can say mirror out of the NFT. That's the reason we are using set token URI, new token URI, again the standard token one, and a token URI, the thing we are fetching from our parameters. Let's give measurements. Okay, so let's build this thing fast. I think we are way far behind from our schedule. So let's go. Your create market item done. It transfer the NFT from seller to marketplace smart contract. As we're mentioning again and again, whenever a user will put the NFT in a marketplace, its NFT ownership will transfer from the owner to the smart marketplace smart contract. Now we're gonna build a new function to resell the smart contract. So again, the same thing will happen. Resell smart token ID will be taken as a parameter, price will be taken as a parameter. We set the to require function. Then the message dot value is is equal to or above Let this add this thing is equal to or above the listing price and require functionality that the owner, the person who placing the NFT must be the owner of that NFT. Apart from all the things we are using strut function, for example, we're changing the functionality. For example, is sold false. Price, the new price we're going to ask from the parameters. Seller, again, the person who is using this function, owner, address of this because he is again transferring the ownership from himself to the NFT marketplace smart contract. And this is done by using address of this an item sold value, which we use to filter out which NFT will is on the NFT marketplace and which item is on sold. Then we will decrement this thing and again transfer the ownership part. Tool. Again, the create market sale, this function is used to create the sale of the NFT. You're going to check that the value that is sent for buying this NFT must be greater than the price or equal to the price. And again, the struct is used to change the values. For example, owner will become the payable dot message dot sender. The person who click on the function to buy the NFT sold is true. Seller will be changed to zero. Now NFT marketplace don't own anything. And again, the transfer function, payable function is same thing. Now this is function to fetch all the unsold NFT. Again, this is a getter function. It is a read-only function, so this it will cost no gas. You're going to take the current amount of NFT has. For example, our platform have minted 20 NFTs. For instance, this is 20. Unsold items will be 20 minus item that is current. As we know and above, we are whenever an NFT will be sold, we are increasing the item sold number, and whenever an NFT is minted, we are increasing the token ID's value. So, for example, 20 minus 6, 14. This is the logic behind this read-only function or getter function. And by using looping, we're going to get the items in array. We create a new market item array. And again, struct allows us to create our own data type. So this market item is a data type. Think of it like uint array memory items. But instead of uint is a market item, our own customized data type. I know I'm rushing, but again, time is a constraint here. Again, this is a read-only function. Fetch my NFT. This function will fetch all the NFT my address or I own. So how this thing happen? Again, item count, the item that is on currently on. We can going to use loop, and the biggest factor is this line. By using the struct we are checking that we're getting the address of the owner of the NFT. So think of that like we have 5 NFTs in our marketplace. We are checking who's the owner of this NFT. If the owner of that NFT is equal to message or sender, us or user A or user B, it is true. And after that, customize new array will be assigned to this and this, and we get to know that this NFT is owned by us. So again, this is the getter function, so it will not cost any gas. This is the fetch item listed. So it gives all the NFT that a user have minted and listed on our marketplace. Again, the same logic, but instead of dot owner, it use dot seller. And apart from that, all the function are same. All the logic and functionality is same and pretty layman, if you think about that. Mhm. So this is again a new getter function. Basically, we're getting the balance of this smart contract. This is very standard line and it is used in every smart contract. So you will memorize this after you wrote two, three good smart contracts. Add the dot this dot balance. Simple thing but effective. This is another function. This is withdraw function. So basically, if you see, if someone is generous enough to donate to a smart contract instead of just listing to a smart contract, then this withdraw function came in handy. The amount it is going to drain the balance of a smart contract, and sometimes to network congestion. I don't know if you know about contract congestion, but sometimes your transfer got cancelled due to blockchain congestion or block network congestion. So by adding this require function, our money, our crypto is safe with us. And to receive any money, any cryptocurrency in any smart contract, we need to add this to function or special function, you can say, which is receive and fallback. Receive is used when message or data is empty, and fallback is used when message or data has some value. What is message or data? Basically, whenever you send some crypto, you have the option to send some string along with it, some value, some message along with it. So if a user send one ETH and send a message that good work, it will going to the fallback function. And if you only send one ether, it's going to get called by receive function. I guess our smart contract is completed. Again, this kind of smart contract, like 260 lines of smart contract, cannot be built in 1 hour or 1.5 hours. That's why I have to rush this thing. So if you have any question, logical question, I'm open to answer. I know I'm rushing this thing, but that's the time constraint problem. Anyone, any question? No worries. Let's move to the bigger part, new part, better part. So now we're going to compile our smart contract and check if there anything we messed with this thing. So again, this hardware.config.js script we have discussed yesterday. So basically we are using hardware tools again, pretty standard, pretty standard, pretty standard. You can use either of one of them. It's up to you. But again, I think hardware buffer is being depreciated now. So let's comment this thing. .env. So basically we are telling the script that you have to fetch this value from .env by using this package. And hardware data scan to verify our smart contract on the Polygon scan to make sure that users that our smart contract are doing what we are saying. Again, default network hard hat for testing purposes. API private key, as we discussed earlier. You have to create your own .env file, which I have not created yet. So let's create one. You need to put all this value in your .env file. and add a git ignore. .env is already here. So let's create another one. We add our .env file here. Now hard hat so OTT version 0.8.4, but we are using same version. So basically, they tell the hard hat you have to install 0.8.4 so OTT compiler to compile our smart contract. For Etherscan, we are using Polygon Mumbai because we are deploying our smart contract to Polygon Mumbai, and we have to use Polygon scan key to verify our smart contract. Now we're gonna use yarn hard hat compile to compile our smart contract. Right, wrong, either we mess up this thing. We mess this thing. Let's see what this is saying. What mistake have we done? First of all, our name is not right. Fetch items. Again, yarn had compile. New problem. Spelling mistake. Line 58. Owner. Let's again do this thing. Compile. Now again, beautiful. Good. A smart contract is working. It is compiling. Now move to our deploy script. Deploy script is again very standard. We have used this yesterday. Here we go. We are using HRI from Hardhat, NFT Marketplace. This is the most important line. Get contract factory. We have to put the smart contract name in this NFT Marketplace in this parameter. Apart from that, everything will be same. Deployed. We're getting the address, and now we are verifying our smart contract within the deploy script. We are not creating a new verify script, which we created yesterday. So sleeping verify yes. So this sleep function we use to set the price. So basically we are waiting for 100 seconds here. And now use the line to compile which is yarn header run script deploy JS Mumbai network. Go for this. Slip, yes, this thing is happened. We deploy a smart contract. Cool. Now we, so let's check our smart contract with the polygon scan. Change to Mumbai test network. Here we go. Here we go. Time is running out. Here we go. We have deployed our smart contract part, but yet it is not got verified. So it is on bytecode, and I don't think anyone is genius enough to read this bytecode. So that's why we are verifying a smart contract, which is sleeping. It's going to take 1 minute second, basically 2 minutes, and after that you're going to verify and run the verify script. So basically 3 minutes max to max if everything went right. And yes, you have deploy your smart contract part. Again, anyone have any doubt? Any doubt? Any doubt? In smart contract part, deploy script part, dot config part. Done. You see, our smart contract is verified, and if you check this thing, don't have a tick mark of a green tick mark, but this smart contract will get one. You see this thing and this thing. This green tick mark show that you are a good smart contract developer, and this thing so you are noob. You're trying to do rig pull. If you have this, you're genuine product, you have a right product, you're trying to contribute in Web3 ecosystem if you have this thing. And you can write your smart contract. Apart from that, the biggest thing you will get now, you can interact with your smart contract from Polygon Scan or any blockchain explorer. You can do anything like create token, literally anything, create market share, approve, resell token, every function we have created and every external and public function that the libraries have in import. Apart from that, we can also read our smart contract part to check what the person is doing. For example, the thing we can get balance. Currently, his balance is zero, while the listing price is this. And if you copy paste this thing and go to Ethereum converter, ETH converter, you check this will be 0.05 ETH, like this 0.05 ETH. So again, our smart contract is completed. Time is very less. That's why the rush we have faced. Any doubt? If no doubt, I think we can leave. We will create the front end tomorrow.
Your Twitter ID.
Sorry?
Your Twitter ID. Twitter ID.
Oh, Twitter ID. I'm sending you the link. Somehow they're not allowing the underscore.
And dude, are you saving this in the GitHub?
Yep, I am deploying.
No, are you saving the code whichever we've written right now in the GitHub?
Yes,
Okay, thank you.
my screen is this is GitHub desktop. Everything is updated on real time. Anything else? Krishna? Krishna Pro? Pro, anyone, any doubt? Any suggestions?
Thank you, Ayush. Is the session over, right?
Over.
Today we finished the back end of the contract, right?
Yep.
Cool, cool, cool. If you could figure out in some way that where we could integrate the code sandbox, that would be great because we need to when find this up faster because they need to get their certificate sorted and everything. Let's get on a quick call and discuss this how we could do this. Okay,
Cool.
and yeah, guys, in the best practice, Ayush is trying you to get the best experience out of coding. Okay, so kindly, if you are able to install GitHub and Yarn, that would be best. Okay, how was the session today? Can please someone open the mic and speak? Shubham, Shubham.
There will be a lot of background noise from my side. I can't speak right now.
Okay, Ranjit, Ranjit, buddy, Ananta.
Yeah,
Hello.
Krishna, tell me what. Yeah, Krishna, tell me.
Yeah, how was the session today, buddy?
Uh, the session is good, dude. I'm just like figuring out things right now. I'm just looking at the code and figuring out things. Am I audible?
Yeah, you're audible, audible.
Yeah, that's it. I'm just like looking at the code and figuring out things, what is what, where things go, and I guess I'll Google up some stuff which I didn't understand, or else I'll just ping Ayush in through Twitter. Is that okay, Ayush? If I don't understand things, hello.
Hello. I'm saying that using Google is the best practice. So if you know how to use
Thank you,
Google, you
guys.
become
Thank
invincible. While if I help you, you can kind of become dependable. So try to go for Google, and if you can't understand, then please DM me.
Yeah, sure. Thank you, Root.
thank you, thank you, guys. Thank you, Ayush. Let's catch up tomorrow. Thank you. Bye bye.
Okay, bro.
I think everyone can leave the session now.